Alright, today we're going to be graphing square root and cube root functions and transforming them. So we're going to start with the square root function. Mother square root is y equals the square root of x. And it looks like half of a parabola. Okay? The other half is there, but the only way it would graph it is if you graphed both y equals a positive square root of x and y equals a negative square root of x. If you graphed them both, a plus or minus, you'd get the other side of the parabola. But the square root function is just the positive side, so that's why there's only half of it there. Okay, so let's look at, here's mother, and here's all of the transformations that could happen. Okay, every one of these, the negative, the a, the negative, the b, the h, and the k, they all affect and transform and shift the original function. So if outside is negative, let's talk about the vertical transformations first. If outside is negative, that's going to reflect over x. And what you do mathematically is you multiply the y's by -1. The a, if it's bigger than 1, is going to cause a vertical stretch. If it's a fraction like 2/3, 1/5, anything between 0 and 1, then it's going to be a shrink. And your k, that's the other thing that's outside, is going to be a vertical shift up if you're adding, down if you're subtracting. Sorry. Okay, your horizontal shifts and transformations are the things that are on the inside, the negative, the b, and the h. If there's a negative in there, that's going to reflect over y. Mathematically, you multiply your x's by -1 or divide, doesn't matter. Your b is going to be a horizontal shrink now if b is bigger than 1. You'd think bigger than 1 would make a stretch, but remember, anything with my crazy x is backwards. So if it's bigger than 1, it's going to cause a shrink. And if it's little, meaning a fraction between 0 and 1, it's going to cause a stretch. Mathematically, you divide your x's by the b. Your h, that is going to be a horizontal shift left if you're adding h, right if you're subtracting h. Mathematically, what you do is you add or subtract that number from or to the h's or the x's. All right, and then your cube root function. Here's mother cube root. Again, they just got these points by generating some points. You can generate bazillions of points. These are just easy ones because, again, I don't want to do decimals. So if I pick -1, y equals the cube root of -1, I get -1. So that ordered pair would be -1, -1. If I plug in 0, y equals the cube root of 0, I get 0, which gives me 0, 0. And if I plug in 1, y equals the cube root of 1 is 1, which gives me 1, 1. Could you pick other points? Sure, I could pick 5. Y would equal the cube root of 5, which is going to be 1 point something, 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 something. Okay, which I could graph. Okay, I don't know, what is the cube root of 5? 3, 9, 5. No, it's 1.709999999. And which you can see over here at 5, 1.79. It's close, okay? But I don't want to graph 1.7999999. So I'm going to stick with, again, it's not wrong, it's just not very easy to do math with. So I pick these 3 mother points, okay? And then you do the math for that, just like we did with quadratics. Okay, so again, square root general function part 2. To graph a general square root function, you're going to generate your 3 ordered pairs. You can use any ones you want. I just always use these that I showed you how I got. I just always use them for square root, 0, 0, 1, 1, 4, 2. And then we do the math, just like we did on our quadratics. Okay, do all your stuff to x in PEMDAS order. Do everything to y in Everything you do to y is done in PEMDAS order. Anything you do to x is done in ASMEDEP order. Okay. Same with the cube function. It's just that the mother points are going to be different. You start with 0, 0, 1, 1, and -1, -1. Alright, so again, they're just showing you kind of what it would look like if you reflected over the x-axis. And again, I told you to reflect over x, you multiply the y's by -1. If you look at the original function, that point is 8, +2. If I change the y coordinate, that would make it -2, which puts it down here. So it was up here, it reflected over x. This point on the original If I multiply y by a negative, I would get negative 8 positive 2, which puts it up here. So you can see that this was below and it reflected up. Okay? That's reflecting over x. When you have a negative on the inside and you reflect over y, I said multiply the x's by negative 1. Well, again, if you look at my original ordered pairs, if I multiply 1 by negative 1, I get negative 1. So it flips it over the y-axis. And if I take my original 4, 2, and I multiply x by a negative, I get negative 4, 2, which puts it over here. And you can see the whole function reflected over y. Alright, so it says describe the transformations, then graph both functions. Mother, since we're doing square root, let's call her m of x, mother would be the square root of x, which passes through 0, 0, 1, 1, 4, 2. Those are the 3 points that I memorized. 0, 0, 1, 1, 1, 2, 3, 4, 2. There's mother in red. Okay? So let's look at our first function. This negative on the outside is going to reflect over x. The positive 2 on the inside is going to make it go left 2. Mathematically, I'm going to take my ordered pairs, 0, 0, 1, 1, 4, 2, and I'm going to do the math. The negative on the outside means I multiply the y's by negative 1. Which gives me 0, 0 still, 1, negative 1, 4, negative 2, and I've done that. To add 2, or it wants me to add 2 to the x's, but remember that means left, so I'm actually going to subtract 2 from my x's, and I get negative 2, 0, negative 1, negative 1, 2, negative 2. And if I plot those ordered pairs, sorry I didn't want to use red again. If I plot those ordered pairs, negative 2, 0, negative 1, negative 1, 2, negative 2. And if I plot that, knowing it should look like half a parabola, there it is. Did it go left 2? Yes. Did it reflect over x? Yes. Okay. Now, let's graph the other one. For this one, the negative on the inside is going to reflect over y, and the plus 2 on the inside is again going to go left 2. Now, both of those things are on the inside, so we're doing them both to x. This is multiply, this is add. We have to go in Asmodep order, so I have to do adding first. So I'm going to take my ordered pairs, my mother ordered pairs, and I have to add 2, well actually I'm going to subtract 2 from all of my x's first. So minus 2, minus 2, minus 2. That gives me 0, negative 2, 1, negative 1, 4, 0. And then I'm going to multiply or divide my x's by a negative. So negative 1, divide by negative 1, divide by negative 1, or multiply, either way. I'm going to get 0, negative 2, negative 1, negative 1, negative 4, 0. If I plot those, 0, negative 2, negative 1, negative 1, negative 4, 0. And it looks like this. Okay? And you can see that it reflected over y, so it turned it this way, and then it actually, why did it go down to? Should be over here. Oh my goodness, this should be over here like this. And if you look at what I did, where did I subtract my 2 from? I subtracted it from the y's, and you can't, you have to do it from the x's. Oh, be careful. So sorry, my friends. See, even I can make mistakes. Alright, we got to back up. I apologize. Be very careful. See how fast that can go wrong? All right, my bad. Pay attention. Oops. Okay, so I have to do this first to the x's, Miss Hamilton, to the x's. So I'm going to minus 2 from the x's, not the y's. All right, so I'm going to have negative 2, 0, negative 1, 1, 2, 2. And then I'm going to divide by a negative. So divide by negative 1, divide by negative 1, divide by negative 1. I don't want that color. Okay, so that would give me 2, 0, 1, 1, and negative 2, 2. Now let's plot those points. 2, 0, 1, 1, negative 2, 2. There we go. It reflected over y, and it moved it to the right 2. And you're going, why did it go right 2, Miss? You said it was going to go left 2. But remember I told you, when you factor, if I rewrote that and factored out the negative, it would actually be a negative times x minus 2, which is why it actually went right instead of left. Okay? All right. So now let's do a cubic one. Mother, cubic, let's call her mother, m of x, is the cube root of x, who passes through negative 1, negative 1, 0, 0, 1, 1. Negative 1, negative 1, 0, 0, 1, 1. And again, you have to be careful because it looks like you can connect those dots and make a straight line, but you know a cubic is an S-curve. This thing snakes around like that. There's mother. There's the mother cube, okay? The first one, we've got a negative on the outside, which is going to reflect over x. We've got a minus 2 on the inside, which is going to move me right 2. So we are doing one thing. This happens to y because it's outside. This happens to x because it's inside. So the order I do this in really doesn't going to matter because I'm only doing one thing to each. It's only when you do two things to the same variable that you got to pay attention to either PEMDAS or ASMEDEP. So I'm going to go ahead and multiply the y's by, or divide, multiply the y's by a negative. So times negative 1 times negative 1 times negative 1 on the y's. I get negative 1, 1, 0, 0, 1, negative 1. That's done. Then I have to add 2 to my x's. So plus 2, plus 2, plus 2. I have 1, 1, 2, 0, 3, negative 1. And if I plot those ordered pairs, 1, 1, 2, 0, 3, negative 1. And again, you got to kind of pay attention. I know this thing reflected over x, so it turned upside down. So this thing is going to snake backwards. Okay? That would be the f function. Now, to do g, we have a negative on the inside, which is going to reflect over y. And we have a minus 2 on the inside, which means it's going to go right 2. Except for it's really going to go left 2 because of if I factor out the negative. But anyway, this says multiply your x's by negative 1. And this says add 2 to your x's. This is multiplication, this is addition. You're doing two things to the same variable, so order matters. And when you're doing things on the inside to x, you don't do it in PEMDAS order, you do it in ASMEDEP order. So I need to add 2 to my x's first. So I'm going to take my my mother pairs, negative 1, 1, 0, 0, 1, 1, and I'm going to add 2 to my x's. That's going to give me 1, negative 1, 2, 0, 3, 1. That's done. That's done. So now I'm going to reflect over y, which means I'm going to divide my x's by negative 1. And that gives me negative 1, negative 1, negative 2, 0, negative 3, 1. So if I plot those points, negative 1, negative 1, negative 2, 0, negative 3, 1. Okay, this was going to reflect over y, so it's going to, again, look backwards. So it's going to snake like this. Okay? Alright. So you try this one. Hit pause. Come back when you're ready. Come on. Stuck. Alright, to solve this one, again, and guys, you can use your mother points if you want to, but in a multiple choice situation, you know that mother looks like this, and this is going to go to left. So you want the same picture 2 units to the left, which is that one. Done. Okay. Try this one. Hit pause, come back when you're ready. And hopefully you got D. Again, you can do the ordered pairs, but I know that this negative is going to reflect over y. And this should go 5 left, but because if I factor that negative out, it's really going to go 5 to the right. So you see how this went 5 to the right and then reflected over y. Went the other way. Instead of going to the right, it went to the left. Okay, so it's got to be D. You could also do the ordered pairs. Okay, try a cubic one. Hit pause, come back when you're ready. And hopefully you got C. If not, let's look at Y. We know that this negative is going to reflect over X. And we know that this plus 3 is going to move it left 3. So, again, cubics are a little bit harder to kind of just move in your head. So I'm going to use my ordered pairs. So I have -1, -1, 0, 0, 1, 1. That's for a cubic. The negative on the outside says multiply my y's by -1, which gives me -1, 1, 0, 0, 1, -1. And I did that. Then I'm going to subtract 3 from my x's. -3, -3, -3, -4, 1, -3, 0, -2, -1. And if I plot those points, -4, 1, -3, 0, -2, -1, and I connect to make my S, there's your graph. Okay. Try another one. Hit pause, come back when you're ready. And hopefully you got A. Alright, this one's a square root function. I know that the negative on the outside is going to reflect over X. The plus 2 on the inside is going to go left 2. And the 2 on the outside is going to go down 2. Mathematically, what that means we're doing is we're going to multiply the y's by -1. We are going to subtract 2 from the x's, and we're going to subtract 2 from the y's. So if you see, I have 2 things happening to y. Those I have to do in PEMDAS order. So I'm going to multiply first. So if I take my mother pairs for a square root function, which we did 0, 0, 1, 1, 4, 2, I got to multiply by -1 first on the y's. So times -1 times -1 times -1. I get 0, 0, 1, -1, 4, -2. That's done. This says subtract 2 from the y's. That gives me 0, -2, 1, -3, 4, -4. And then it wants me to subtract 2 from my x's. So that's going to give me -2, -2, -1, -3, 2, negative 4. And if I plot those ordered pairs, negative 2, negative 1, negative 3, and 2, negative 4, and I know it makes half a parabola, there's my graph. Alright, some homework help. They give you this function, 2.9 times the square root of x plus 20.1. It models the median height, f of x, in inches of boys who are x months of age. So x represents their months, how old they are in months, and the y-axis represents their height. So it says, describe how the graph can be obtained using transformations of the square root function, square root of x. Well, guys, they moved 20 units higher, didn't they? So wouldn't I take the mother function and add 20 to the end? Wouldn't that make the square root function shift up 20.1? Well, actually, it's going to shift up. They gave me the actual function. So it's going to shift up 20.1. And you see the 2.9 on the outside? That means it's going to be, so they want me to describe, that means that it's going to be up 20.1, and it's going to have a vertical stretch of 2.9. Okay, B, according to the model, what is the median height of boys who are 48 months? Now, when they want you to use the model, they're telling you to use the function. So if I take my function, 2.9 square roots of x plus 20.1, and they gave me an age, which is an x value. So they're telling me to plug in 48 for x. So 2.9 square roots of 48 plus 20.1. And we just use a calculator to solve that. I mean, we would, if they wanted radical, we would just leave it, but they want a decimal answer. So 2.9 times the square root of 48 plus 20.1, and I get 40.19. Okay, which means my f of x, or the height of a kid that's 48 months old, should be 40.19. Okay. Use a calculator and round to the nearest tenth of an inch. So that would be 40.2. Okay, and it says the actual median height for boys at 48 months is 40.8. How well does the model describe the actual height? Well, the graph says 40.8. The model, the algebra, says 40.2. They're pretty close. So how well? Pretty well. Because those are really close together. Okay? And then it says C, use the model to find the average rate of change in inches per month between birth and 10 months. Round to the nearest tenth. Alright, the average rate of change is kind of like a slope. So they want birth and they want 10 months. Okay, so at birth, if I plugged in 0, I'd have 2.9 square roots of 0 plus 20.1. This is all going to be 0, so f of 0 equals 20.1. That ordered pair would be 0, 20.1. To find at 10 months, okay, so we're plugging in 10 for x, I'd have 2.9 times the square root of 10 plus 20.1. And if I use my calculator, I get 2.9 times the square root of 10 plus 20.1. I get 29.3 if I round to the nearest tenth. So now to find the average rate of change, that's slope. That's y2 minus y1 over x2 minus x1. So I would have let's go y2 down here. 29.3 minus 20.1 over 10 minus 0. 29.3 minus 20.1 is 9.2 divided by 10 is going to be 0.92. So the average rate of change is about 92%. Okay? And D, you're going to do the exact same thing, but you're going to use 50 months and 60 months and see how it compares to your answer in C. Alright, so how do you graph square root functions? You use your mother points, 0, 0, 1, 1, 4, 2, and then you perform transformations. And you could describe them if you want. What does A do? What does H do? What does K do? But you perform the transformations, and then you graph new ordered pairs. And you got your transformation. How do you do cubic functions? Same as square root, except for your mother points are -1, -1, 0, 0, and 1, 1. 3. When there are multiple transformations to form, what order must be followed? When you're doing transformations on y, you go in PEMDAS order. When you're performing operations on x, you go in ASMODEP order. And 5 says, does this function and this function have identical graphs, and explain why? And you do that. Find your ordered pairs, plot them, and then I want you to explain what you see and why you think you're seeing that. Alright, so we are at homework, which means we are done. So happy homeworking, and I will see you next.